I'm Nick Arcusa, Senior Technical Marketing Manager at F5, and I'm joined today by Mikhail Fedorov, who's going to be doing some demos. And the topic of the conversation today is distributed cloud and ways to move faster in distributed cloud when you're deploying distributed applications. On the left-hand side, we are setting up this context around distributed cloud journey. The fact that customers' needs commonly revolve around a faster way to get end user applications in front of the end users. So actually improving the global delivery of applications for a global user base. Points such as being able to securely connect services when you do that. So once you deploy your applications to edge locations, we need to be able to connect these services. And then also, most of the services these days are microservices based. So how do you control and discover APIs that these services use? And finally, once we have all of the services and the apps all over the place, how do you protect these workloads? And how do you make sure that this protection is done from one place with a full scope of visibility? So the topic of the discussion today is addressing these needs with F5 Distributed Cloud. And we have a set of demos that we'll be focused on, and we'll try to keep the slides to a minimum, but very quickly focus on some interesting demos in order to showcase how we leverage the app delivery network within F5 Distributed Cloud, which is a distributed Kubernetes, virtual Kubernetes deployment to deploy container-based workloads around the globe, how to be able to connect multiple sites, which is multiple locations of different clouds in order to connect services, how to enable API discovery and control those APIs, and finally, how to protect the applications using a F5 Distributed Cloud WAF. These are the key topics for us to address today. And to set the context, let's talk about a little bit the value proposition of the distributed cloud, which is really around running and connecting these modern microservices apps securely. The four major stops that we'll be making along the way is, again, focusing on how to take an application that's container-based and be able to quickly run it in a global distributed fashion on a global network, which is the ADN, Application Delivery Network, component of the distributed cloud. Number two, which is the circle number two, and some of the bullet points down below address it, which is how do you optimize and connect across multiple clouds and connect securely across multiple clouds to ensure that these different services talk to each other. We will also talk about API discovery and control, and Mikhail is going to show a quick demo of how distributed cloud enables that. And specifically, when you are trying to expose and manage APIs, for example, if you expose APIs to third parties, then third parties are consuming these APIs in certain ways. Well, how do you get visibility into who's consuming what? And how do you restrict and potentially control some of the ways these resources are consumed, whether it's being to restrict specific routes on an API or methods. And we will talk about that. And finally, getting this one single pane of glass when it comes to security. And to help us with all of this, we had to come up with a very simple but interesting, we think interesting application, which we call Arcadia Finance. It's a microservices-based app, and we have multiple services that we're deploying and connecting along the way. So our first stop is going to deploy a common module that you've seen probably in your bank. It's a mortgage calculator. You can request mortgage rates based on a zip code in the US. In Europe, could be a postal code or some other address-based information. And based on some inputs, you quickly get a mortgage rate calculated for you. And what's important here is to be able to do so fast and do so very quickly at the customer edge. And we'll show you how we accomplish this with the Distributed Cloud ADN. So that is the first step on our journey. The second step is, now that we have established that we have several services, we had built several modules that you can see on the right-hand side. One is called Refer a Friend, runs in a private data center, running in VMware. Another one runs in AWS Cloud, and this is the core application. So it talks back and forth between the mortgage calculator and the Refer a Friend module. And then finally, within Azure Cloud, we run a money transfer module. And all of these separate modules need to talk to each other. And certain modules have to be visible through a L3, L4 sort of layer 3, layer 4 networking construct. So you'll be able to ping, for example, a resource from one direction, but not necessarily be able to see a resource from another direction. And also doing that on layer 7, being able to access specific resources via HTTP, for example. We already talked a little bit about the API usage. This is going to be a kind of third stop. And what we're doing here is we're exposing a transaction API, which, as I mentioned before, runs on Azure. And we're exposing this API as a subset of an open banking spec in order for third parties to be able to consume transactions. It's a very common situation, being able to pull a transaction API from your bank. If we're exposing this to third parties, we definitely want to make sure that we know how these third parties are using the APIs. And finally, how do you protect all of these different services in different clouds? Do you deploy multiple WAFs, web application firewalls across different clouds and try to manage them with policies, which creates all sorts of inconsistency problems? Where's the common source of truth? Can you deploy a better solution and run a better solution for application security to protect all of these workloads and get one common set of insights across all of these deployments? And the answer is yes, we can do that with a 5 distributed cloud, and we'll show you how. All right, not going to spend too much time here. Essentially, what we're outlining here is the couple of concepts. So ADN, we already talked about them. Application Delivery Network, typically focused on improving app performance. Multi-cloud networking, really it's just about connecting across multiple sites, app services, enabling different teams and lines of business to talk to each other. API discovery really is a concept around, well, if I don't know much, if I don't have an API spec, for example, a Swagger-based spec, how do I find out about my application, what APIs are being used? And API discovery is a really cool service where, based on some machine learning and AI, we're able to very quickly identify which routes are in use, how they're being used. And finally, a concept, a WAP, it's the Web Application API Protection, essentially a WAF service plus API security integrated together and attached to a load balancer. So from an architecture standpoint, this is a very quick way to kind of think about what we'll be going through. And I'm not gonna spend too much more time on the slides, and let's just start getting into the actual deployment, talk about kind of the 4 different use cases that we have thought through here using different modules. And all of our demos will have a common theme, which will be before and after. So we will first try to connect a calculator, mortgage calculator module, which runs in the global network. Then we will connect the money transfer module, refer a friend module, and finally we'll start talking about exposing the transfer API modules. All of these different modules represent these microservices-based services, which are very common. And as you can imagine, for demo purposes, it's kind of cool to be able to say, hey, okay, we're connecting first of all, L3, L4, and then we're connecting L7, and we're going to connect to other services and make them all work together. All right, so first of all, let's talk about Application Delivery Network. I already mentioned this. This is really all about speed, improving the application delivery to the edge. And one of the key things is to be able to move application services that are not just very, very lean, possibly Node or JavaScript or something, a WebAssembly-based modules, but move any container-based service closer to the end user. And this is one of the big value propositions of 5 distributed cloud, is being able to support a container-based application service. So you can move it from, let's just say, AWS to the regional edge, closer to the user in multiple different locations, by providing a native Kubernetes environment for developers with very familiar tooling, and being able to very easily lift this container, a full container with a full runtime, which is very different from running a PaaS, platform as a service type solution, for example, or running a very small subset of runtimes like WebAssembly, for example, in a regional edge. Here you can run a full application and being able to take this very quickly, connect it across multiple regions very seamlessly using the application mesh. And we will take a look at the demo to show you how we do that.
So this is the before state. We have an application, Arcadia mortgage calculator, and you can see that it's coming soon. And now we're going to opening up the virtual Kubernetes that we already pre-configured ahead of time. And what we'll do here is we'll create a new virtual Kubernetes workload, which means that this is all of the metadata and all of the description that's required for us to configure this container workload. I'm going to call it the web server. It will have several parts. The web server will load specific arguments needed to run the PHP code in our container. And again, as I mentioned, we're going to have two containers in one pod. One is going to be running the web server. The other one is going to be running the fast CGI process, which we just configured. And finally, a shared volume. And this shared volume will allow us to share the data across and be able to copy PHP source to the shared volume in order to make this application run. As you can see now, we're advertising this deployment through Volterra and mapping the port 8080 into a HTTPS load balancer in 1 second. And Volterra handles all of the certificate generation. It makes it very easy to select your container-based workload, few clicks, and deploy. So it will take couple minutes for this to actually get rolled out on our virtual Kubernetes. And now we're going back into Vault console. We'll see that this workload is now running. It's now deployed across these multiple nodes across regional edge. And right away, we actually see this mortgage calculator working. So the application pulled it automatically. We can see now we can do a purchase price and some kind of down payment amount. And once you punch in a zip code, the calculation now happens on the regional edge, and it's very, very fast. So the application that is used here is not the backend app somewhere, on your old mainframe if you're an old bank or running somewhere on-prem. This is all happening on the regional edge. And this is the value of being able to go to the regional edge very quickly with Volterra, just taking the container and deploying it.
Yeah, so as you saw, it's very, very easy to deploy a container-based application, ADN, and realize multiple types of benefits. And different customers will use them in different ways. So you can see on the left-hand side is a gradient of optimizing this user experience, starting with simple termination, SSL terminations, TLS, certificate management, to more comprehensive, latency-sensitive services being moved to ADN, to actual front end being moved to ADN. Finally, a full application backend and app tiers moving to ADN, ultimately to an in-store compute, meaning that your retail in-store functions could be also moved to the distributed cloud, and this creates multiple different improvements in latency. And when I click go in this video, you'll see the animation where on the left-hand side, you'll see baseline, which is the kind of standard what the application would perform like. And you'll see the marginal improvements with each one of these as you kind of go through and think about the latency. And we've done this test actually for real. We deployed our services and checked how fast they load. So when I click go, you'll see that the in-store compute is already instantly loaded, front end is next, and then SSL, and finally baseline. And each one of these improvements in the retail scenario is a saving. And it has a tremendous business impact. There's actual data points about how e-commerce entities, so some of the largest e-commerce sites, can lose millions or billions of dollars if their latency is high when they load the page resources or site resources, and could add to the bottom line if their content delivery is faster. So the business impact is definitely there, very, very visible. All right, so we talked about the application delivery using the global sites or the global network and the application delivery network. Now that we have some services running in different places, how do you connect them? So let's talk about AMCN, which is the concept around multi-cloud networking. And when we come to, again, from a customer perspective in our Arcadia application, some of the key value propositions around connecting across services to be able to do so securely. So how do you connect from one cloud to the other and do so in a way that reduces the operational complexity and increasing that agility, observability of how all of your resources are routed. And that is what the F5 distributed cloud provides, is this consistent, single, simplified, and secure stack which connects multiple application resources. And in this case, we're looking at, at the baseline of sort of like a L3, layer 3 connection. And then we also will look at a separate demo focused on layer 7. But in this case, let's start with the question of very easily connecting across multiple clouds, in this case, AWS to Azure, in order for our transfer module to be able to talk to the core application.
Again, like before, we're going to show you the before scenario. So here you'll see the coming soon on the left-hand side, on the right-hand side, sorry, means that this capability isn't turned on. Now, the way we're going to prove it also is you're going to see we're pinging now from AWS a IP address in Azure, and we're pinging from Azure an IP address in AWS. And you can see that there is no data received or sent. We can't ping the two resources. Now, we cheated a little bit here, and we already have two sites set up ahead of time for AWS. And all we're doing now is creating the connection. Now, the one thing that we'll be doing here is creating a global network. So think about this as this way. A site can be connected to a global network, and then another site, for example, in our case, Azure, is going to be also connected to the same network. So when the two sites are connected, so in this case, we're going to Azure VNet, and again, we're going through and editing this object and selecting the existing global network that we just created earlier, connect global network. It's already there in the dropdown, global net. Now, AWS and Azure are both connected, and the only step that's remaining for us to do is to configure routes in our cloud providers. So this is the way it's done in AWS, and here we have it done in Azure. And this way, both are able to access now this global network, and we can ping from each one of the providers, as you can see, quite literally immediately, this connection. And now when we refresh the page on the right-hand side, you see that this module is now turned on and working. So essentially the AWS backend that runs and runs the front end of this application is now able to access the Azure capability for the transaction.
Now let's talk about doing the same thing, connecting two different services, but at the layer 7 connectivity using the HTTP load balancer. And we have a module, which is a refer a friend module running on VMware, actually. And we're going to be connecting. And why is it running on VMware? It's because maybe we store some data. There's some privacy concerns. We want to make sure it's running on-prem. We want to keep the data close to us in the data center. And we still want to connect to the core application and do so securely. So F5 distributed cloud to the rescue. Let's have a look at how we accomplish that.
Okay, as before in the demo, we're going to compare the coming soon scenario. In this case, you'll see this module that's running on VMware. And the first thing we'll do a curl from AWS to VMware environment. Nothing's coming through. We'll configure the DNS setting to point to Vault Mesh, and then we're going to go into our VMware environment. And here, let's take a look at the IP address of the resource, this refer a friend IP address, .240. All we have to do then is start configuring, again, the HTTP load balancer in this case. And as before, we have the site configured ahead of time, so VMware site is configured. If you want to see how it's done, Pranav has a great session on, it's called Application Mesh, App Mesh, where he goes into much detail as to how it's done. But here we're just configuring the refer a friend load balancer and the origin pool that points back to this IP address that we identified earlier. This is the VMware environment .240, and this would allow us now to advertise this internal resource into our AWS environment. And what we're doing here is creating a HTTP connection between our VMware environment and AWS. So again, through a couple of clicks, now we're going to just select advanced fields, advertise into our desired environment. And, again, this is the ease of configuring, such as, this internal AWS environment inside network. We advertise this resource into it. Couple clicks, all done pretty much immediately. And within a minute, we are now able to go back into the application and doing the same exact curl and take a look at now the refer a friends based on this DNS entry, and it comes back with 200. Okay. If we click refresh in the application, now you see the invite a friend capabilities turned on. So just like that, we'll see the load balancer is configured, and this resource, which was on-prem resource, is now talking to our application securely.
Now that we have connected all of our services, deployed different services across multiple clouds, the question is, how are we using these services? Because most of the time, the modern applications would be API-based, and we could have API traffic running back and forth. So REST APIs, Open API spec. What that sometimes we do have as developer teams may be maintaining applications in a very robust way and publishing their API specs. Maybe we have API specs for third parties, which is also great. Obviously, third parties in this case, Arcadia is opening up a API for the transactions using the open banking spec subset. But what if there is not sufficient documentation of these APIs? What if maybe a team had previously worked on a project, abandoned it for some time maybe, and new team is picked up and maybe they don't document the APIs very well? This is a very common scenario. Like most of the brownfield application services are not very well documented. API specs may be outdated, may not be in Swagger format. The question is, how do you then find out what your APIs are and how they're being used? And this is where F5 Cloud Services provides the built-in AI and machine learning-based approach to help you discover the APIs by listening in on the traffic that flows through the load balancers, and to be able to build a visual of what you have and provide the telemetry for you to be able to then make decisions as to which APIs to control and how. So I'm going to ask Mikhail Fedorov to jump in with a demo to show us how exactly that's done. Take it away, Mikhail.
Hello, this video about API discovery functionality in a F5 distributed cloud. In order to enable API discovery on a load balancer, application type has to be created and assigned to target load balancer. To assign application type to load balancer, application tag has to be created with reference to application type profile. Once done and some traffic went through load balancer, API schema is ready, and user can see what exactly endpoints in use on the dashboards. For example, on this dashboard, you can see all the information about TPP payments endpoint. In addition to that, API schema can be downloaded in the form of Open API file for later use with other tools. Once API schema is discovered, we can use this information in order to actually enforce it and only allow traffic to existing endpoints. In order to do that, I'm going to use service policy assigned to a load balancer. As you can see, by default, all endpoints are allowed, and I'm going to create a service policy to block some endpoints. Service policies have nested structure. They may contain one or more rules. In this particular case, I'm creating a rule to block requests with method equals any, path prefix equals tpp/banks. So I want to block all requests going to tpp/banks API endpoint. Service policy is ready, and now I can assign it to the load balancer. Assigning the policy, click apply, click save, and that's it. Configuration is ready. And if I send exactly the same request again, this request will be blocked because I have service policy in place. As you saw in this video, API discovery functionality allows to discover all active API endpoints, download API schema in the form of Open API file, and then enforce positive security model using service policies. Thank you for watching.
All right, thanks, Mikhail. So finally, now that we have connected our services, we have our application running across multiple clouds, we have seen how APIs are being used, and we have this visibility, let's talk about how we secure everything. So Arcadia, as a representative multi-services app, is deployed across different environments. In our scenario, we deployed them for fun, so to speak, in Azure and AWS and in on-prem and in regional edge ADN, just to prove a point that apps can be deployed and running multiple locations. Most of the scenarios that customers use these days don't require all of these clouds and probably won't have all of these clouds, but it is a representative scenario of a complexity of a architecture that has multiple services that are exposed. And the question is, how do you secure all of that? And one of the approaches is to easily bolt on protection for these MCN workloads, these multi-cloud networking workloads by a 5 distributed cloud, where you can add a set of protection from a WAF, web application firewall, attached to a load balancer, to bot detection and protection, attached to a load balancer, to DDoS protection, et cetera, et cetera. And that is the value that distributed cloud brings in, where you can not only attach the various different security services, but you can also integrate the data and integrate the insights that come across all of these services for one common place to observe, manage, and control all of your security stance. So I'm gonna ask Mikhail to jump in and give us a demo of how that works, and then we'll wrap up.
In this demo, I'll give a short overview of all available features and briefly explain how they work. First of all, we should understand that WAF enables on the load balancer and then protects all traffic that flows through. In order to enable a WAF, I should open a load balancer configuration and select Enable WAF. Once WAF is assigned, there are two options for me. First is to take pre-created WAF profile, and the second one, create my own. This is exactly what I will do right now. At first, I am choosing enforcement mode. It defines will the WAF block bad requests or just alert on them. Protection-wise, there are two options. First is to use default detection settings, and the second one, customize it to better fit application security needs. Since I selected Customize Detection Settings, now all security features available for me to configure. First two features, Attack Types and Signature Selection by Accuracy, allow me to define what attack signatures will be enabled in this profile. Automatic False Positive Suppression feature uses machine learning to reduce amount of false positives. Threat Campaigns help to mitigate zero-day attacks with attack signatures that come from our security team just in hours after threat has been reported. And violation detection settings allow to disable unnecessary violations. For bot protection settings, there is a similar approach. A user can use default settings or customize action based on the bot type. These are all features available in the WAF configuration profile, but there are more features to protect HTTP traffic. Once I enable Show Advanced Fields in the load balancer configuration profile, all of them become available. The first one that we will take a look at is Trusted Client Rules. So this is basically a law list and allows to skip any security checks for the specific IP prefix. So the clients which come from this IP prefix will never get blocked or alarmed. All the features that we have discussed so far do not require any knowledge about the application structure. However, it's often required to allow only traffic that is allowed to go. For example, to establish a positive security model. This is exactly what service policy is used to. It allows to match traffic by specific metrics and requests and apply rules to those requests. Service policies are organized in a nested fashion. They may contain one or more rules that actually contain requests matching criteria and an action. In this particular example, I am going to create a rule that matches requests by path value and basically blocks a specific URL. I want this rule to work for any HTTP methods, and my path value is tpp/banks. So I'm going to block tpp/banks URL for any methods. Then I click apply, and this rule appears in the policy. All policies have implicit deny all rule at the end. So in order to allow all other traffic, I want to create explicit allow all rule. So to do that, I select any method and nothing else. So this rule works for any request. So my service policy allows me to block specific URL and allow all other traffic. Next feature that I'm going to highlight is rate limiting. It works exactly like as it sounds and allows me to limit the amount of traffic that comes from the single source in the period of time. In this particular example, I'm allowing 5 requests per second with burst multiplier 2 from a single IP address. The last but not least set of features I'd like to mention today is machine learning based features. Currently we have 3 of them: API discovery, DDoS detection, and malicious users detection. API discovery feature allows to automatically discover API or application structure and then download this information in the form of open API file. DDoS detection uses machine learning to identify the good traffic baseline and then, based on this baseline, find the anomalies and report them so a user can take protective actions. Malicious users detection also uses machine learning in order to identify bad behaving users on various metrics such as request rate, WAF violation rate, and so on. Once bad users are identified, an administrator can take actions on them.
Thanks, Mikhail. All right, so in just a few minutes, we went through this interesting use case around a company that has leveraged distributed cloud, F5 distributed cloud, to do a distributed cloud deployment. So again, from the tooling standpoint, and you can see we kind of highlighted this in the middle, we have a common control management plane across multiple different personas, from dev to DevOps to NetOps to SecOps. All of these personas can use the role-based access to F5 distributed cloud to manage the different aspects of the deployment. Being able to see the insights from the application stack to the networking to the security, and being able to control how these services are exposed to third parties. Also gain insights and capture the data from logging, from alerting, and get the insights and visibility across multiple environments, be it in public cloud, private cloud, and leverage modern services-based application and containerized deployments in multiple ways at the edge, in different public clouds, and in the private data center in a consistent way. That is what F5 distributed cloud enables, is the common control plane, a common management plane, and a consistent networking stack with the mesh approach, with the ability to connect across sites, as we saw in the original demo for layer 3 or 4, being able to connect app services, which is layer 7, being able to see the application API and services used for discovery, and finally to securely control and securely protect all of these workloads. With that, thank you very much. And we hope that you see other sessions on distributed cloud. Take a look at how the distributed cloud addresses many of the customers' concerns, similar to our scenario, and we hope to see you soon.